Alright, Math 3, Practice 2B.2.1, Solving Rational Equations. The idea with solving rational equations is we want to get rid of fractions. Okay, to do that we need to multiply. Because we have equations, if we multiply something to the left side, we multiply it to the right side. So that's the trick we're going to use here. So I look at these and I say, okay, what can I multiply by to get rid of all my fractions? Well, I need to multiply by 3. I also need to multiply by x minus 4. So if I times by 3 times x minus 4, if I multiply that by every single piece here, I can do it because I'm timesing by every single piece. Then what that'll do is get rid of everything I need to get rid of. So let me show you how it would work. Let me give myself a little more space. So I have x plus 3 over 3. So I'm going to times by 3 times x minus 4. Then plus, I'm going to times by 3 times x minus 4 to my 5 over x minus 4 equals 5 times 3 times x minus 4. So the 3's cancel, and I've got x minus 4 times x plus 3. So I go x times x, which is x squared, x times 3, 3x, negative 4 times x, negative 4x, negative 4 times 3, positive 12. Okay, obviously I can adjust that. Negative 4x and a 3x would give us a negative x. Oops, and that was minus 12. Okay, plus x minus 4's cancel. I have 3 times 5, which is 15. Equals 5 times 3 is 15, times x is 15x, times 4 is negative 60. Okay, now I need to get everything on the same side as the x squared. So I've got negative 15x. So I end up with x squared minus 16x. Negative 12 plus 15 would be a positive 3, plus 6 would give a 63. Okay, now I can graph this, use a calculator, do whatever to solve. So I'm going to factor. Factors of 63 that make negative 17, 7 and 9, if they're both negative. So I get x minus 7 times x minus 9, set them separately equal to 0, and we get a positive 7, and same thing for the 9, we get 9. So my answers are x equals 7 and 9. Now, if I plug 7 in for x, will it become 0? No, so I don't have to worry about that. Okay? And that's the whole process. So it's kind of a lot of work, isn't it? But that's what we have to do to make it work. Okay, so number 2, same idea. 2x and x plus 1, so if I times everything by 2x times x plus 1, I'll get rid of all my fractions. So 2x times x plus 1 times 3 over 2x plus that same thing times 2 equals 2x over x plus 1 times 2x times x plus 1. So x plus 1's cancel out. So 2x and 2x gives me 4x squared. Then let's do this side. 2x gets canceled. 3 times x, 3x. 3 times 1, 3, plus 2 times 2x would be 4x. 4x times x would give us 4x squared plus 4x. Now this one's nice because if I subtract 4x squared from both sides, they cancel out. So then I combine 3x and 4x to get 7x plus 3 equals 0. Subtract 3. 7x equals negative 3. Divide by 7. And x equals negative 3/7, which if I put in for 0, or put in for x, they wouldn't be 0 because I'd need either a 0 for x or a negative 1. So that one would work. Okay, now let's take a look at number 3. Okay, so we've got x minus 3, then 3 minus x. But if I first take out a negative 1 from that, I would have negative 3 plus x. So if I go x minus 2 over x minus 3 equals x minus 1 over negative 1 times negative 3 plus x, okay, which would be x minus 3. So we times by x minus 3 to everything. At negative 1, it's like it's times them by that whole thing. Okay, so those cancel. I'm left with negative 1 times x minus 1 equals, those cancel, 2, x times x, x squared, x times 3, 3x. So I end up with this. So this multiplied gives me negative x plus 1. So I add x, subtract 1, we end up with x squared minus 2x minus 3. So factors of 3 would be negative, it would also be 2, 3, and 1 if 3 is negative. So x minus 3 times x plus 1. So my x's are going to be x equals positive 3 and negative 1. Now, if I put a positive 3 in for x, I get 3 minus 3, which is 0. So 3 actually can't be an answer, so negative 1 is my only option on that one. Okay, so there's those 3. That's the simple stuff. Now we're going to look at some, I suppose you could say, some story problems that go along with this. So what we're going to be talking a lot about on these ones, oh, by the way, don't do question number 9. I have tried and tried and tried. I can't figure it out. I don't know how they're getting it. I know one way, but it seems like such a stretch that it doesn't make sense to me that that would be the right answer. So we're not going to do number 9. I can do all the rest though, so we're good there. Okay, so let's actually start with 5 and 7. Okay, they're kind of weird. So 5 is, can x equal negative 2 be a solution for this? Well, put it in for x. Negative 2 for that x would give us 0, right? Negative 2 plus 2 is 0. So the answer is no, because we can't have something over 0. Okay, number 7 says the reciprocals of 2 consecutive positive odd integers. So a positive odd integer would be like 1, 3, 5, 7, 9, 11, and so on. Consecutive mean here and here. Reciprocals mean 1/3 and 1/5. So which would have a difference of 2 over 63? Well, 63, if you split that apart, that's 7 times 9, right? So is 7 and 9 2 consecutives? Yeah, if we found their integers, or their reciprocals, we'd have 1 over 7, 1 over 9. If we subtract them to get the common denominators, we'd end up with 9 over 63 and 7, so 9 minus 7. So yeah, so our answers are 7 and 9. Okay. Now we're going to talk about some work problems. So number 4. Gideon can rake his lawn in 3 hours. His friend Katsuro can rake a lawn the same size in just 2 hours. Suppose they worked together to rake Gideon's lawn. What rational equation represents the information presented in this problem? So what we're thinking here is, they're called work problems. They're based off this idea that the rate times the time gives you a distance. Our distance being raking a lawn. Okay, rate being how fast they're working, and time being the time. Okay, so what we can do is, if we're solving for like time, we could divide by the rate and we'd have d over r equals t. Okay, well, if rates are variable, right off the bat we've got a rational. So Gideon can do it in 3 hours. Okay, so here's another way. We could even divide by t and get d of t over r. Okay, so he's raking along in 3 hours. So he would have one lawn that he rakes in 3 hours. Katsuro can do it in 2. So he'd have 1 lawn that he rakes in 2 hours. Okay? Now, if we add those together, we want to know how long would it take them to rake 1 lawn. How much time together? Okay, so we could leave it like that, or we could say, well, I don't like this t here, so let's times everything by t. And I get t times 1, so t over 3, plus t times 1, t over 2, equals 1. Okay? Now, could we figure this out? Yeah, it didn't ask us to, but I'll show you how you figure it out. So, to get common denominators, we times this side by 2, this side by 3. So I'd get 2t over 6 plus 3t over 6 equals, actually no, we don't want to do it like that. We could do it this way, but there's I think a better way. Okay, 3 and 2 make 6. So if I times everything by 6, we're going to get rid of stuff, right? Because 6 is 2 times 3, so 3's cancel, I get 2t plus 2 times 3. 2's cancel, I get 3 times t. That's more like how we did these ones. Then 1 times 6 is 6. 2t and 3t give us 5t equals 6. Divide by 5. So we get t equals 6 over 5. Now, 6 over 5, that would be 1 hour and 1/5. So 1 would be an hour, 1/5 would be, well, let's see, if we cut 60 into fifths, that would be 12 minutes. So 1 hour, 12 minutes. But what we wanted was the formula for the answer. Okay, now number 6, it says, it takes Lena 8 hours to paint a particular size room, but her co-worker, Neela, can do the same job in 7 hours. If they paint it together, how long will it take them to finish painting the room? Okay, so to paint one room, Lana takes 8 hours. Neela takes 7 hours to paint one room. Okay, we add it together. We want to know, okay, how long is it going to take them for one room? Okay, so let's, we could times by t first. Okay, but we may want to times by something else too, right? Because 7 and 8, 7 times 8 is 56, so we want to times by 56t, because that'll get rid of stuff. Or I could phrase it this way. I want to times by 7 times 8 times t. 7 times 8 times t. 7 times 8 times t. So 8's cancel, I'm left with 7t times 1, plus 7's cancel, 8t times 1, equals, t's cancel, 7 times 8 is 56 times 1. Okay, so we get 15t equals 56, divide by 15, and we get t equals 56 over 15. Which, if we do that, we get like 3.73 something, 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 something. Okay, other stuff. But we could round at 3.73 hours. Okay, 0.73 of an hour is almost a fourth. A fourth is 45 minutes, or no, 15 minutes for 1/4, so 3/4 would be 45 minutes. So about 3 hours and 45 minutes. Okay. All right, let's take a look at number 8, because we already did 7. Chris has access to 2 different water sources for filling up his swimming pool for summer. One source, using a rigid pipe, supplies water 50% faster than the other source, which uses a flexible hose. Using both the pipe and the hose, Chris can fill the pool in 6 hours. How long would it take to fill the pool if he only used the pipe? Okay, so let me give myself some space. So the way we have to think about this, I don't know how long we've got the hose and we've got the rigid. Okay? The hose, okay, takes us however long to fill up. Time, right? The rigid one can fill up that same amount of time, but it can do it quicker. Okay, how much quicker can it do? Well, it does it 50% quicker, which means if it did it at the same rate, that would be 100%. So 50% quicker would be 150%, or 1.5. Okay, and the same amount of time. Okay, so in other words, we think of it more like this. Okay, The hose, to fill up the pool, the hose takes a certain amount of time. The rigid pipe can fill up a pool and half of a pool in that same amount of time. We add them together and they're going to take 6 hours, which to fill up that pool together it took 6 hours. So I'm going to multiply everything by 6t. Okay? If I times by 6t, I get rid of all my fractions. So 6's, I'm left with t. Okay, equals, the t's cancel, 1.5 times 6 is 9. T's cancel, 1 times 6 is 6. 6 plus 9 gives me 15. So, for the hose, which was just t, takes 15 hours. So, thinking about, dividing that by 1.5, that gives us the pipe, which is 10 hours. I believe that's what they were looking for. Okay, now number 9. If you can figure this one out, I will give you some extra credit because I could not figure it out. And I talked to some other teachers. I did a lot of work. I thought of it different ways, but I just can't come up with an easy way to understand what you can do to get it to work. I can figure out the problem doing one thing, but that seems so far out that I don't know how you'd ever think of that. Okay? Alright, so let's take a look at number 10 now. A passenger train is 40 miles per hour faster than a freight train. In the time it takes the slower freight train to travel 161 miles, the passenger train can travel 301 miles. What is the speed of each train? Okay, so looking at this one, this one we kind of have to think of it differently. And here's how I figured this one out. So I went D equals R times T, okay, and then I said, alright, so what do we know? Well, I know that the passenger train is 40 miles faster than the freight train. Okay, I also know that in the same amount of time, they can travel that same distance. So I went like this. I said, okay, so let me get time by itself. So I have D over R equals T. Then I said, okay, well, the distance of the freight train was 161 miles. Okay? And it had a certain rate. And in that same amount of time, the passenger train traveled 301 miles. But its rate was 40 miles per hour faster. So my rate is going to add 40. So now these are both equal to time, so I can set them equal to each other and solve. So I'm going to multiply by R times R plus 40. I'm multiplying by both denominators because that eliminates those R's. 161 times R is 161 R. 161 times 40 is 6,440 equals R plus 40 cancels, and I'm left with 301 R. Okay? So then I subtract 161 R from both sides. And I get 6,440 equals 140R. Divide by 140. Not R, just 140. And we end up with R equals 46. So the freight train travels at 46 miles per hour, which means the passenger at 40 more is 86 miles per hour. Okay? So, there we go. Alright, so, I bet you thought I was done, didn't you? I figured out number 9. Now, I had figured it out the whole time. The problem was I checked the answer on the book, and the answer on the book was like totally off. It was like 5/3, which was a crazy answer because it didn't make any sense. Because what I did was I thought about it like this, okay, using that same kind of the distance equals the rate times the time, okay. I looked at it this way and I said, okay, so on the skateboard, okay, she went 12 miles at a certain time, okay. On the bike, she went 12 miles, but she did it in 2 less hours. Okay. Now, also her rate was twice as much here, which means if we think, or twice as fast, I should say, not twice as much, which means that we can take this, that we can set them equal to each other if we double this. Because it would take her twice as long on this one to get to that same rate here, so I'd go 24 over t equals 12 over t minus 2. Then we'd multiply by t times t minus 2. The reason we multiply by both denominators on both sides, by doing it on both sides, we are able to keep the same answer because we have an equal sign. By times and by t, we get rid of t. By times and by t minus 2, we get rid of t minus 2. We just have to multiply by the same things. So then I get 24t minus 48 equals 12t. Okay, so I subtract 24t, and I end up with negative 48 equals negative 12t. Divide by negative 12, and we get positive 4 equals t. Okay, so what that means is it takes us 4 hours on the skateboard and 2 on the bike. Now, I had gotten this same answer trying this problem out so many different ways that I was really starting to wonder. I had some other math teachers take a look at it, and we realized that their answer of 5/3 was super crap. So, anyway, there we go, guys. You're welcome, and enjoy.